Namaste students. Last week we have seen the types of matrices, addition of matrices, subtraction of matrices. This week we are going to see the transpose of a matrix, right? So what do you mean by transpose? It's nothing but interchanging the rows and columns. Okay, so if A equal to Aij be an M cross N matrix, then the matrix obtained by interchanging the rows and columns of A is called the transpose of A. So we denote this by A transpose or A dash. So now let me see one example. Okay, so we are taking one matrix A equal to 3 5 root 3 1 0 1. What is the order of this matrix, students? How many rows are there? 3 rows. How many columns? 2 columns. So order of this matrix is 3 cross 2, right? So how to find the transpose of this means we are going to just write the first row as first column. So 3 5. Second row as second column. Root 3 1. Third row as third column. So what we did here, we changed the rows as columns. So this is called the transpose of a matrix. So we're going to change the first row as first column, second row as second column, third row as third column. Okay, let me see one more example. So it's given B equal to 2 3 1 1 4 3. So how many rows are here? 2 rows. How many columns? 1 2 and 3 columns. So what is the transpose for this? Can you tell, students? The first row will become the first column. The second row will become the second column. So this is the transpose of matrix. So what is the order of this? How many rows? 3 rows and 2 columns. So you can see the order of a matrix, right? If it is 2 cross 3, then the transpose order will be the reverse of it, 3 cross 2. Okay, so let me go for the next sum, students. The next one will be properties of transpose of matrices. So the first property is A dash the whole dash, or A transpose the whole transpose is equal to A. The second property is Ka the whole dash is equal to Ka dash. That is the constant. You can take that outside. The third property is A plus B the whole dash is equal to A dash plus B dash. The fourth property is AB the whole dash is equal to B dash A dash. Okay, so now we are going to see the next topic is symmetric matrix. So a square matrix A is said to be a symmetric matrix if, what is the condition for symmetric matrix? If A equal to A dash. This is the main formula for this. If A equal to A dash, then that matrix is called a symmetric matrix. Very important conditions. So if you have this word symmetric matrix, you can tell A equal to A dash. So let me see one example now. So this is the matrix. A is equal to root 3 2 3 2 1 0 3 minus 1 1. So can we find A dash for this? That is the transpose for this. So what is the first row here? That will become the first column. 3 root 3 2 and 3. Second row will become second column. Third row will become third column. Can you see both the matrices are same? After interchanging also we are getting the same matrix, which means A equal to A dash. Therefore this matrix is called a symmetric matrix because we are getting A equal to A dash. The next one is skew symmetric matrix. Okay, skew symmetric matrix. A square matrix is said to be a skew symmetric matrix if A dash equal to minus A or A equal to minus A dash. You can use any of the two conditions. A dash equal to minus A or A equal to minus A dash. If you're getting this condition, you can say that it is a skew symmetric matrix. So let me take this example. B equal to 0 E F minus E 0 G minus F minus G and 0. Can you find B dash for this? So the first row will become the first column, second row will become second column, third row will become third column. See, 0 EF, here also 0 EF, but one negative is outside. The same way, minus E 0 G, E 0 minus G, F minus F minus F minus E 0, F G and 0, which means B equal to minus B dash. So which means it is a skew symmetric matrix. So students, can you understand? If a matrix is called a symmetric matrix, then A equal to A dash. If a matrix is said to be a skew symmetric matrix, if A or B, whatever the alphabets you're taking, that should be negative of the transpose. Okay. So now you have two theorems here. The first one is, for any square matrix A with real numbers entries, A plus A dash is skew symmetric matrix and A minus A dash is a skew symmetric matrix. The theorem 2 is, any square matrix can be expressed as the sum of symmetric and skew symmetric matrix. Okay. A very important conditions we are going to use here is sum of symmetric and skew symmetric matrix. You all know that A plus A dash is a symmetric matrix, A minus A dash is a skew symmetric matrix. So this is a 4-mark question. Express the following matrices as sum of symmetric and skew symmetric means you should use this condition. Okay, now let's go for the exercise 3.3. Find the transpose of the following matrices. Okay, they are given you one matrix. Can you tell how to find the transpose of this? What is the first row here? 5, right? Second row is 1 by 2. Third row is minus 1. So the first row will become the first column. Second row will become the second column. Third row will become the third column. So this is the transpose of the first question. The next question, find the transpose of this matrix, right? 1, minus 1, 2 and 3. So how to find the transpose? The same way, first row will become first column. Second row will become second column. The next third question, they are given minus 1, 5, 3. 5, 6, root 3, 5, 6, 2, 3 minus 1, which is equal to, the first row will become the first column, second row will become second column, third row will become third column. So this is the transpose. So whether it is a 1 cross 1, whether it is a 1 column matrix, 2 rows 2 column matrix, 3 rows 3 column matrix, the procedure is same. Is the second question in the exercise. If A is equal to minus 1, 2, 3, 5, 7, 9 and minus 2, 1 and 1, B equal to minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1, then verify A plus B the whole dash is equal to A dash plus B dash. So first we are going to find LHS, then we are going to find the RHS. This is A, this is B. So first you find A plus B. Okay, so what is your A plus B? I am going to add A and B, right? So minus 1 minus 1 minus 4 will become minus 5. 2 plus 1 will become 3. 3 minus 5 will become minus 2. 5 minus 1 is 4. 7 minus 2 is 5. 9 minus 0 is 9. Minus 2 plus 1. So actually we are first we are going to add a plus b. So minus 5 3 minus 2 6 9 9, and minus 2 plus 1 will become minus 1. 1 plus 3 will become 4. 1 plus 1 will become 2. So this is your a plus b. So what is a plus b the whole dash? Can you tell, students? A plus b the whole dash is, first row will become first column, right? So minus 5 3 minus 2 6 9 9 minus 1 4 2. So this is your a plus b the whole dash. This is the LHS. Now I am going for the second part, that is a dash plus b dash. So what is a dash here, right? Can you see this question? A dash, first row you change it as column, right? So it will become, I am writing it here, minus 1 2 3 5 7 9 minus 2 1 1. This is your a dash. And b dash, right? The same way b dash, I am going to find the transpose of b, that is minus 4 1 minus 5 1 2 0 1 3 1, right? So now you should find a dash plus b dash. So I am going to add a dash plus b dash, which is equal to, so I am going to add these two matrices, minus 1 minus 4 minus 5, 5 plus 1 6, minus 2 plus 1 minus 1, 2 plus 1 3, 7 plus 2 9, right? 1 plus 3 4. Last row, 3 minus 5 will become minus 2, 9 plus 0 9, 1 plus 1 2. This is your second equation. Now you can check the first and second equation, you are having the same numbers. So which implies, right, which implies a plus b the whole dash is equal to a dash plus b dash. So whatever the matrix given, you can do in this method, whether it is a plus b or a minus b, whatever it is. Okay, students. Third question, if a dash is equal to 3 4 minus 1 2 0 and 1. See, listen carefully. A dash is given in this question and b is given minus 1 2 1 1 2 3. And what is a? The first row will become the first column. So we are changing a dash to a here before going into the sum, and we are writing b as it is. So we want to verify a minus b the whole dash is equal to a dash minus b dash, right? So like the last sum. So first you should find a minus b. Okay, so what is a minus b here? I'm going to just subtract those two matrices. 3 minus of minus 1 will become 4, right? Minus 1 minus 2 will become minus 3. 0 minus 1 will become minus 1. 4 minus 1 3. 2 minus 2 0. 1 minus 3 minus 2. This is a minus b, and we are going to find a minus b the whole dash. So a minus b the whole dash is equal to, so the row will become column here. So this is your a minus b the whole dash. So now this is the first equation. So now we are going to find a dash. A dash is nothing but the transpose of a, right? So 3 minus 1 0 4 2 1. This is a dash, and we are going to find b dash also here. So we are going to find the transpose of b, which is given in the question. So you will have minus 1 2 1 1 2 and 3. So now what we are going to do here, the question is a dash minus b dash, right? So I'm going to subtract these two, a dash minus b dash. So what is 3 minus of minus 1? Plus 4, right? The next one, 4 minus 1 is 3. Minus 1 minus 2. Minus 1 minus 2 is minus 3. 2 minus 2 is 0. 0 minus 1 is minus 1. 1 minus 3 is minus 2. You can see first equation and second equation is same, right? So which implies a minus b the whole dash equal to a dash minus b dash. The next question, a dash is minus 2 3 1 2 and b is equal to minus 1 0 1 2. Find a plus 2b the whole dash. Okay, so here they are asking a plus 2b, but here it is given a dash, so you first convert a. So how to find a? Minus 2 3 1 2. So this is a. So they have not given the question directly, we should find a from the given question. So and what is b given here? Can you write that? Minus 1 0 1 2. It is given directly, so very simple only. A plus 2b the whole dash, right? So first you should find this. So a value is minus 2 1 3 2. This is your a, and 2 into b. So 2 into minus 1 0 1 2. So I have not taken dash now. First I am simplifying what you have inside the bracket. So you will have minus 2 1 3 2 plus minus 2 0 2 4, right? So now we are going to add minus 2 plus minus 2 minus 2, right? It will become minus 4. 1 plus 0 1, 3 plus 2 5, 2 plus 4 6. This is your a plus 2b. So they are asking a plus 2b the whole dash. So we are going to find the transpose of this. So this is the answer. Fifth question. For the matrices A and B, verify that AB the whole dash is equal to B dash A dash. A is given, B is given. Okay. First we should find AB the whole dash is equal to B dash A dash. Here we are completely going into the multiplication. So AB means, what does it means? First row, first column, right? First we are going to find A, B. So AB is nothing but first row, first column, right? So 1 into minus 1. First row, second column. 1 into 2. First row, third column. 1 into 1. Next, second row, first column. Minus 4 into minus 1. Minus 4 into 2. Minus 4 into 1, right? 3 into minus 1. 3 into 2, 3 into 1. Normal multiplication, what we have seen in the last class. See, now this is your AB. Just simplify this and write minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6, 3. This is your AB. And AB the whole dash is equal to minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6 and 3. This is your AB the whole dash. Keep this as first equation. Now the next part is B dash into A dash. So what is B dash? We should find the transpose of B, right? So that is minus 1, 2, 1. Yes, B dash we are getting. So now I have to find A dash, right? A dash is nothing but, so 1 minus 4 3. So this will become 1 minus 4 and 3. The same way, can I multiply this now? Can you help me? First row, first column, right? So first row, first column, minus 1 into 1. Next, first row, second column, so minus 1 into minus 4. First row, third column, minus 1 into 3. Next, 2 into 1, 2 into minus 4, 2 into 3. 1 into 1, 1 into minus 4, 1 into 3, right? So you will get here minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4 and 3. So you can see the first equation and second equation are same, which implies AB the whole dash is equal to b dash a dash. So listen students, one thing I want to tell you, suppose the question is verify that ab dash is equal to b dash a dash. Sometimes it may come, but this is a property, so definitely it should come for us. Suppose they are asking you prove that, which means definitely you will get the answer. In that case, there is no other option. If you are not getting the answer now, you should check whether you have done any mistakes anywhere. Okay. The sixth question, if a is equal to cos alpha sin alpha minus sin alpha cos alpha, then verify that a dash a is equal to I. So a is given, a dash we want to find first. See, a value is cos alpha sin alpha minus sin alpha cos alpha. So okay, this is your a value. So what is a dash? Can you tell that? This is a. A dash will be cos alpha sin alpha minus sin alpha cos alpha. A dash a. So I am going to multiply a dash with a, that is cos alpha sin alpha minus sin alpha cos alpha. So first row, first column, so which becomes cos square alpha plus sin square alpha. Next first row, second column, cos alpha sin alpha minus sin alpha cos alpha. Okay, next second row, first column, right? So sin alpha cos alpha minus cos alpha sin alpha sin square alpha plus cos square alpha. You all know identity. This will become 1 0. Why? Because these two will get cancelled, plus minus terms, 0 1. So this is what we want to prove here. A dash a is equal to I. We are getting a identity matrix. The seventh question, show that the matrix is a symmetric matrix. What is the condition for symmetric matrix? You all know that, students. If A is equal to A dash, then we can say that it is a symmetric matrix. So I am going to find A dash. So what is A dash for this? 1, first row will become first column. 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. So we are getting A is equal to A dash, which implies it is a symmetric matrix. Right? The next question, show that the matrix A is equal to 0 1 minus 1 minus 1 0 1 1 minus 1 0 is a skew symmetric matrix. So we are going to find skew symmetric means what is the condition? A is equal to minus A dash. So find the transpose of this. 0 1 minus 1 minus 1 0 1 1 minus 1 0, right? Can you see the difference between the two matrices? Yes, all the numbers are differ only with the negative sign. So if I take on negative outside, I can write this as 0 1 minus 1 minus 1 0 1 1 minus 1 0. So which implies A equal to minus A dash. Therefore the given matrix is skew symmetric matrix. Okay, the next eighth question, for the matrix A is equal to 1 5 6 7, verify that A plus A dash is symmetric matrix. So A is given, verify that A plus A dash is skew symmetric matrix, right? So how to do this? First you find A dash. So A dash is 1 5 6 7. So A plus A dash. So what is A plus A dash? 1 5 6 7 and A dash value is 1 6 5 7. So add these two. 1 plus 1 2, 5 plus 6 11, 6 plus 5 11, 7 plus 7 14. So symmetric matrix, we want to prove A plus A dash. So we are going to prove here. See students, for this question, A plus, this is A plus A dash, right? So finished. So what we want to prove here, A plus A dash is symmetric. Suppose if you want to prove A is symmetric, what you want to prove? A equal to A dash, right? So now we are going to prove A plus A dash is symmetric. So what we want to prove here is A plus A dash is equal to A plus A dash the whole dash. So here I finished finding A plus A dash. So we want to find the transpose of this once again. So if we find the transpose of this, so what I'll get? First row will become first column, second row will become second column, right? So which means, see, this is the first one, this is the second one, right? This is A plus A dash. So A plus A dash is equal to A plus A dash the whole dash. Okay, so which means A plus A dash is skew symmetric matrix. The next one is a very important topic. Express the following matrices as a sum of symmetric and skew symmetric matrix. It is a 4 marks question if it is a 2 cross 2 matrix. If it is a 3 cross 3 matrix, you can be asked in 6 marks also, right? So they are given one matrix and we want to find, express this as sum of symmetric and skew symmetric matrix. Okay, so half A plus A dash plus half A minus A dash. So this is your A matrix. So first we are going to express, we already learned this formula. P is, this is symmetric matrix, this is skew symmetric matrix. The question is, we want to express this as sum of symmetric and skew symmetric matrix. So half A plus A dash plus half A minus A dash. So very simple. You all know how to find A dash, right? So first we want to find P. P is your symmetric matrix, that is half A plus A dash. So half, what is your A here? 3, 5, 1 minus 1 plus A dash. A dash is the transpose of this matrix, right? So 3, 5, 1 minus 1. This is your half, right? Half A plus A dash. So half 3 plus 3 is 6, 5 plus 1 is 6, 1 plus 5 is 6, minus 1 is minus 2, right? This is your P value. If you want, you can divide this 2 inside, so it will go for all the terms. 3 3 3 and minus 1. This is your P, that is symmetric matrix. Now we want to find Q. So Q is nothing but half A minus A dash. So half, what is your A here? 3 5 1 minus 1. What is A dash? A dash value is 3 5 1 minus 1. So half 3 minus 3 0, 5 minus 1 4, 1 minus 5 minus 4, 1 minus of minus 1 plus 2. So again if I divide this by 2, I will get 0, 2, minus 2, 1. Okay, so this is your Q. So finally you should add this P and Q and write, that is, you should express this as P plus Q. That is your final answer. Okay, just write sum of symmetric, that is P plus Q. So I am writing it here. Just note this, students. So the final answer is, where is P value? 3 3 3 minus 1. Don't add, okay? You should write like this only. 0 2 minus 2 and 1. This is your sum of symmetric and skew symmetric matrix for a 2 cross 2 matrix. Now can we do the same for a 3 cross 3 matrix? Here also we are going to express this as sum of symmetric and skew symmetric matrix. So what is P? Half A plus A dash. So half six minus 2 2 minus 2 3 minus 1 2 minus 1 3. This is your A, and your A dash is, what is A dash? 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. This is your A dash. A plus A dash. 6 plus 6 12. Minus 2 is minus 4. 2 plus 2 is 4. Minus 4 6 minus 2 4 minus 2 3 plus 3 6, right? So if you want, you can divide this by 2. 6 minus 2 2 minus 2 3 minus 1 2 minus 1 and 3. This is your P value. So now we are going to do the K, right? That is Q. That is half A minus A dash. That is your half. What is A value? 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. This is your A, minus A dash value is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. You just subtract these two values and check what you are getting here. 6 minus 6 0, minus 2 plus 0, 2 minus 2 0, 0 0 0 0 0 0, right? So the final answer is 1 by 2. That is, we are going to add both P and Q. Q is 0. So the final answer will be 12 minus 4 4 minus 4 6 minus 2 4 minus 2 and 6, right? Or you can divide and write this. So this is the answer. Minus 1 and 3.